Good morning, everyone. A very warm welcome to all of you on this special day as we celebrate the Foundation Day of the Indian Institute of Management, Udaipur. I am Sharmeen.
And I am Ujjwal, and we are honored to be your host for today's momentous celebration. Before we move ahead, I request you guys please rise for the national song.
Founded on July 27, 2011, IIM Udaipur has grown into one of India's premier business schools. As we complete 15 years of this remarkable journey, we take immense pride in being the youngest IIM to receive AACSB accreditation. We have also been featured in both the QS World University Rankings and the Financial Times Masters in Management Global Ranking for 7 consecutive years, a testament to our continued pursuit of excellence and global recognition.
Located amidst the scenic Aravali Ranges, our 300-acre campus is not only an academic hub but a thriving ground for innovation, entrepreneurship, and global thought leadership.
Before we proceed, let's take a moment to revisit the milestones of IIM Udaipur's inspiring journey. We now present a short film that highlights our stories, achievements, and impacts.
We now request the dignitaries to please come up on stage and have a seat. Professor Somak Rai Chaudhary, guest of honor. Mr. Pranay Shule, member of Board of Governors at IIM Udaipur. Professor Ashok Banerjee, Director at IIM Udaipur. Professor Vijeta Doshi, Dean Programs. Professor Anirban Adhikari, Dean Faculty and Research.
It is now our pleasure to welcome our esteemed keynote speaker, Professor Somak Rai Chaudhary, and to invite Professor Ashok Banerjee to present him with a bouquet as a gesture of our warm regards.
We now request Professor Ashok Banerjee to welcome our esteemed board member, Mr. Pranay Shule.
We now invite Professor Vijeta Doshi, Dean of Programs at IIM Udaipur, to deliver the welcome address.
Good morning. It's a momentous occasion, as you know, and it's my absolute pleasure and honor to welcome you all to IIM Udaipur's Foundation Day. It's heartening to see so many of you diverse investors of IIM Udaipur. Why I'm calling you all investors is you have invested your time, you have invested your soul, your heart, your efforts into making what IIM Udaipur is today. So thank you. Really appreciate all your contributions. Chief guest, Professor Somak Ray Chaudhary, very warm welcome to you. Mr. Pranay Chule, Board of Governors representative, thank you for being here. Director Professor Ashok Banerjee, thank you for your vision. Professor Anirban, Dean, Faculty and Research, thank you for all your guidance to the faculty and the institute so far. Students, faculty, staff, families. On this day, I would like to reflect on 9 foundations of IIM Udaipur. We know Foundation Day primarily is on the basis of when the foundation stone is laid. And it gives a very important milestone for any institute to commemorate. Having been with IIM Udaipur for last 11 years, these 9 foundations are from my perspective, my lens. I believe there are 9 pillars of this foundation of IIM Udaipur. Okay, yeah. The first one being the material foundation. Very important. What I said primarily, the foundation stone is what marks the foundation day. Materially, if you say place wise, we have grown in terms of campus, in terms of infrastructure, in terms of physical asset. And in today's digital time, we also know that it's not only physical asset, we also have to imagine digital assets, which the Institute has done so far. The campus you've seen growing. Yeah, now we are coming up with our new phase in the PPP model, wherein we'll have more hostels. We'll also have the MDC Management Development Center. Yeah, so material foundation is a very important dimension of foundation of any institute. The next one is symbolic foundation, the shared collective identity that the institution builds, first of all, and then carries forward. Right? So, our mission is part of that. Our vision 2030 is part of this shared identity and symbolic foundation that we have collectively built. And these are not just hashtags, right? Unstoppable you. From there to today, when we are saying transform you, these are our collective shared identities. And it's a great day where we can together celebrate from where we have come and where we have reached. And we'll set the intention for where we can go from here. Talking about the third one, intellectual foundation. Very important, especially when it comes to IIM Udaipur. We always believed that we are knowledge creators, generators first, and then knowledge disseminators. Right? So whether that's through our research, just now we saw the video, we are worldwide recognized. It's through our research, it's through our programs and the expansion that we have done over the years. It's through our centers. Today we have 10 centers, including the newly set up AI lab. We have 7 degree programs, many certificate programs, right? So that intellectual foundation is also very important aspect of any institute and very true for IIM Udaipur as well. In terms of innovation, intellectual innovation, as an institute, we have been trying out new ways. The most recent one is RITL, Research Integrated Transformational Learning, wherein we are saying, is there a bridge between our 2 pillars of Vision 2030, the research, high quality research, and the transformational learning. How do we bridge that? So, innovation, of course, is very important aspect of this intellectual foundation. Human foundation, very important, whether that's faculty who chose IIM Udaipur, we were just speaking, faculty choosing IIM Udaipur over many other older institutes, right? Whether that's staff, every day what we see, there's a lot which goes behind the stage. So the staff, thank you. You have been a great foundation backbone. Students, what you bring to the classroom, the culture you create outside the classroom, all of that is very important aspect of the human foundation. Alumni, thanks for giving back. Alumni, today I can see many faces from alumni, right? That connect, we really appreciate. Board members, I've been part of a few board members as invitee, and I can absolutely say it's one of the wonderful boards, so much invested, so much giving, very generous with their guidance. And it is through their guidance today we have reached where we have reached. It is through their guidance that we have been able to innovate as well. Right? So, really appreciate this. Recruiters, very important people who bridge your studies and your degree and make it more job ready, right? That connect, that we have families, very important families of staff, even some students, faculty. It is through their support. When we say institute, when we say people, we know the boundary, within the boundary, we have so many people residing, right? It's through their support, it's through their harmony, community, sense of community that we build and claim the institute to be so. Many benefactors, right, who support, let's say, our centers, some of the schemes, progressive schemes for the institute, that part. Then is your cultural foundation, the everyday habits, the values of IIM Udaipur that all of us try to live up to, right? So the routines, collegiality among students, staff, faculty, very important aspect. Temporal foundation, stewardship across generations. Professor Jannat very graciously is here, the founding director. He has been the visionary behind what the institute has achieved so far. I remember it was 2015, 5th March 2015. It was my job interview and my birthday at the same time. I don't know how Professor Jannat figured out that it was my birthday. And after the interview and everything at 6 p.m. in the evening, while I was, I think, taking a walk along Fateh Sagar Lake with my family, I get a call from the director. And you can imagine a fresh PhD, the director calling and saying that you have been selected, and I'm telling you because it's your birthday, right? So you feel the values there, you feel the culture there, right? How you're made to feel. So that's little glimpse, and we know about Professor Janat and his greatness. Okay, moving forward, this is a bit slow. Okay, relational foundation, very important. We often forget the government, right, who supports us in many ways. Our academic collaborators, whether that's for our programs or research collaborators, donors I've mentioned, local communities around us, we are trying to contribute to create that social impact, and of course, global networks. Okay. And finally, of course, let's also imagine beyond IIM as such. When we educate students, our idea is that we are educating responsible youth. We are not only giving degree, but we are creating citizens, responsible citizens, right? Who make the country great, who make this world a great place to live. Right? So that's the foundation, I would say. Collectively, all these eight, as you see, they come together very nicely in having a very aspirational foundation that we have, which is great because it's a thirst now for our even brighter future. So, in conclusion, this is what I'll say, The beginning of the institution may be defined and fixed through date, let's say. But the beauty is that the future is unfinished. That gives the possibilities, the potential for all of us to come together collectively, define what that potential can be, and move towards it. Very happy Foundation Day. Thank you. All the very best.
Thank you, ma'am, for your address. Now, please join us in welcoming Professor Ashok Banerjee, Director, IIM Udaipur, to address the gathering.
A very good morning, Professor Somak Rai Chaudhary, Vice Chancellor, Ashoka University, Mr. Pranay Shule, esteemed member of Board of Governors of IIM Udaipur, my colleagues, Dean Professor Vijay Doshi, Dean of Programs, and Professor Anirban Adhikari, Dean of Faculty Research, the founding director of IIM Udaipur, Professor Janat Shah. He has been very regular in attending all the Foundation Day celebrations. My very dear faculty colleagues and staff, dear students, guests, and members of the family. Exactly 15 years ago on this date, we started our journey with 57 students in the MBA program. And today on campus, we have more than 900 students across various programs. And our growth has not stopped. We have aspirations to become a very inclusive, sensitive, and affordable institution for all aspiring students. Now, in these 15 years of our journey, many things have changed. And you have seen through that video, short video, that what all we have achieved over the last 15 years. But in this 15 years, the world also has changed significantly. Be it geopolitical crisis, be it technological disruption, we are in a new world. I think after World War II, we have never seen such an unprecedented geopolitical risk that we see today. And it has all pervasive effect, impact on countries, sectors, human beings, and individuals. So we have to prepare ourselves to face this new world. Technology disruption with AI is another tectonic shift. And this is not like discovering printing press or railway lines. And because of this uncertainty, what we find in India is that the private sector is not investing. See, uncertainty, financial markets love because the valuation of assets go up in certain times. But real economy doesn't like it. If you look at the data 2023-24, the private sector capex, capital expenditure in India was around 4.2 lakh crore, 4.2 trillion rupees. Last year, 25-26, the data we have for the full year, it has inched up to 4.9 trillion. From 4.2 to 4.9, about 16% increase. If you take out 2 years inflation, there is no real growth in private sector capex. What did government do? 23-24, the government spent about 9 trillion rupees in capex. This year, it is 11.7 trillion. So government is doing the heavy lifting of capex. Private sector is not doing that. Why? Because private sector is uncertain. They are hesitant for several reasons. First of all, it is because of uncertain and uneven demand, domestic demand, I'm talking about. Although there are pockets of premium consumption in India, but by and large, rural consumption, urban consumption overall is not looking up. So private sectors don't know that if I create capacity today, whether there will be enough demand to absorb that capacity. Second problem is we are facing what is called mid-70 crisis. In the 1970s, we had huge excess capacity in many sectors. The capacity utilization was around 75% of the factories. Same is true today. So if the capacity utilization is 3/4, there is still 1/4 left to be absorbed. And that's why private sector is not investing. The third factor is we had a time in the early 2000, early period of this century, when we had a good feeling. Private sectors invested heavily. If you look at the private sector investment data from 2004 to 2008, just before financial crisis, it was huge investments. They created huge capacity. And then came the global financial crisis. So that kind of shaken their confidence, and still they are not recovering from that, and hence hesitant in investing. Fourth reason, the nature of business also has changed over the last 5 to 7 years. Now, whether it is a startup, established entrepreneurs, big business houses, all are talking about asset light models. And in asset light model, you don't need huge capex for growth. That is also causing low private sector capex. But the silver line is everything is not gloomy. There are sectors where investment is happening. So all that you saw, 4.9 lakh crore investment in capex, there are sectors. For example, electronics, semiconductors, data centers, electric vehicles, and so on. These are the sunrise sectors where investment is happening, which means the future jobs will be in these kind of sectors, which means our students should be ready to take up those challenges and be competent enough to work in those emerging sectors. So we have to prepare right now. Don't say that market is weak, market is tight, job market is poor. It is true in some sectors, the traditional ones, but it is not poor all around. But we need to reskill ourselves. We need to create new skill sets. And that's why IIM Udaipur is setting up a center of excellence on AI. It should be up and running from September. And it is from a business school standpoint, we are not an IIT or engineering college. From a business school standpoint, it is quite massive. We are installing 2 units of GPU of NVIDIA with a production level capacity. And our hope is that we'll get, not only it will be used by students, faculty, corporate for training their people, but also they may develop some products. They can beta test those products. We can do sandbox and so on and so forth. So that's one which will give benefit to all our students so that they are ready for this emerging sector. Second, in order to be mentally alert and active, you need to be physically fit as well. So there has been a long-standing demand from the student side to have a full-fledged sports complex. We have some few facilities, and we were lacking on those. But good news is that the construction is going to start very soon, and in another 10 to 12 months' time, we'll have an integrated sports complex with swimming pools, badminton courts, gym, bigger gym, etc., etc. Now, as I started by saying that IIM Udaipur wants to be an inclusive and affordable institution. What we found is that one major barrier for Indian youth is the language barrier. If they don't know English, they can't get into premium colleges, universities, IIMs, and so on, IITs. Unless we break that barrier of language, you cannot call yourself an inclusive academic institution. And therefore, we launched, the admission is still going on, India's first bilingual BBA program, where a student can choose the language between English and Hindi. It's a 4 year course. Admission is going to end this month, but I'm happy to share that we already got more than 1,000 students who enroll for this program. And our aim is to improve the quality of undergrad education, particularly in business in India. And therefore, because it is an online program, scale is not a limitation. It is not limited by the physical capacity of hostels and classrooms. So we are aiming for 10,000, 20,000 students going forward. And the program is designed in such a way that it is very affordable. One can get a degree from an IIM, a 3 year degree at 3 lakh rupees. So therefore, it is affordable and it is inclusive. And that is the way to give back to the society in our humble way that we are trying. And finally, we need to grow physically as well, not only virtually and online. But our problem is that we have limited hostel capacity. So as Dean mentioned, that we have started construction already. Students who come, if you cross your hostel and go to the main gate, you can see construction started. So we are adding around 180 more hostel rooms, including some married hostels, and one guest house, we call it executive hostel, of about 100 rooms. All these facilities will be ready in next 12 to 18 months' time. So there are some physical growth, there are scale up programs that we have. All these are to make you ready for the next 10 years. Thank you so much.
Thank you, Professor Banerjee, for your insights. It is now my honor to welcome Mr. Pranay Shule, member of the Board of Governors at IIM Udaipur and a highly respected leader in the Indian business landscape.
Uh, Hi, Professor Ray Chaudhary, Professor Banerjee, Professor Vijeta, Professor Adhikari, and all the students, faculty, and the other staff members and other attendees. Great to be here. I was thinking, what would be a good theme for my short little conversation with you, and I think for an occasion like this, which is the Foundation Day, probably what I thought would be most fun to speak about would be how it's very difficult to see tomorrow or day after or years to come standing where we are today. And I think that applies to us in our personal lives, that applies to companies, that applies to institutes. Um, and I think that would be a good topic to kind of highlight. As a great man once said, it's in life it's very difficult to connect the dots looking forward. You can always, you can only connect them looking backwards. So kind of, I'm getting a little flashback of where my association with your, I should say our IIM Udaipur started. This is way before I think most people in the room would have known about its existence. I'm talking about the first time that I met Professor Jamat Shah. This is when the institute did not even have a campus. So we were operating from Mohanlal Sukhadia University. I think that was my first brush with the institute. And in a way, if I reflect back, that highlights something important in our culture. We are kind of scrappy. We are builders. Institutes are built not just by buildings; they are built by culture. So I think this institute has had a very builder focused, let's get going type mentality right from the beginning. Um, if I reflect in my own journey, also, for probably most of you don't know, but I grew up in a small town called Dariba Mines, close to Udaipur, about 80 kilometers from here. That's where I studied in a central school. And in my own journey, also, I never thought that I would do things or go to places that I went to, etc. So I think for us, if we bring it all together and we see our institute's journey here, um, yeah, so now we have a beautiful campus. So slowly we got this campus. I remember visiting the Balicha area where, Professor Shah was starting to plan the institute's build out, and we were looking at the plans and so on. And then Professor Banerjee came on board. We slowly discovered many things. We had long discussions about how to focus our institute. I remember discussions about research going back right from the beginning. I think one of the things we discussed was one way to build leadership of our institute would be to make it very strong in research, which is also very important for attracting great faculty. So we kind of discovered that through our own discussions, that would be an area of focus. Another big shift in our thinking, or I would say step forward in our thinking, was how do we focus or position our institute. Obviously, there are older IIMs and other good institutes in the country. And we had long discussions. I was also a member of the academic council at that time in the institute. And we figured that digital would be a good area for us to focus on. So that was another step in our journey where we started the DEM program. And I still continue to believe that, given the way the world is changing, that's a great positioning to have. Obviously, we have older IIMs, other good institutes, and so on. But I don't think anybody has very crisply owned that positioning. So as we are moving forward in our journey, that positioning I think will serve us well. Now, where do we go from here? Um, I think in terms of if you go back to what I started with, which is it's very difficult to imagine how far you can get standing where you are today. So I think given the way the world is changing, the fact that we have one of the younger IIMs actually works in our favor. We don't have the burden of legacy. We can be more experimental. We can take a few more risks. We are not what I would call the incumbents. In some ways, that's the business speak. Typically companies that are established, when waves of innovation come, in those waves, the incumbents often lose, and it's the disruptors who win. So, we are going through in our, I think, industry, business, life, society, world, like this huge shift that is happening because of technology, AI, and so on. It's changing the very nature of business. It's changing the nature of how people learn. It's changing the, nature of education itself. So if we kind of embrace that change, um, I think we can come out, we can leapfrog, many of those who've been around for, decades before us. So it presents a unique moment in time, and I would just ask all of us to kind of embrace that change. Rules are being rewritten right now because of what, I mean, everybody's talking of AI, but there's a reason for it also. I think this time it's not like the some I mean technology industry always is very good at creating or coming up with waves, right? There was a web 3, there was a meta world, and so on. But I think fundamentally, if you see this time, it is genuinely a disrupting force. It is genuinely changing the way we think, how we work, and so on. And it's a change that that definitely for a business school can be can bring very interesting opportunities the way we position ourselves. So I would just on this wonderful day ask all our faculty, all our students, everybody to kind of embrace that change and discuss and think hard what opportunities that presents us. And younger institutes actually can go very far, very fast, and I don't think we have any better example of that than Ashoka University. So our chief guest here, Professor Ray Chaudhary, he's the vice chancellor of Ashoka University, which, as I'm sure all of you know, it's a great example of success. This is an institute, Professor, it's less than 15 years old, 12, 14. Yeah. And it's kind of completely owned that positioning of you can create a world-class institute focused on liberal education, which was kind of a big gap in our country before. So we have, a great example in front of us to see how these things do become reality. And I would ask us to maybe focus on the whole wave of disruption that AI is bringing and technology is bringing with the same sentiment, with the same passion, and make it happen. So yeah, nice to be here again, seeing all of you. The auditorium always has a few more people than last time, so great to see the institute growing, and hope to continue to see it grow. Thank you.
Thank you so much, sir. We now take a moment to recognize and appreciate faculty and staff members who have completed 10 years of dedicated service to IIM Udaipur. We request Professor Ashok Banerjee and Mr. Pranesh Shule to present the awards. Faculty member Professor Arundhati Bhattacharya. Now, the staff members will be felicitated for their 10 years of unwavering service. Dr. Arvind Sharma, Mr. Maredla Uday Bhaskar, we now move to the presentation of Research Paper Publication Awards for research contributions by a staff member. I request Professor Ashok Banerjee to kindly present this award. I request Mr. Pramod Kumar to kindly come forward and collect the award. Thank you, sir. We now request that all the awardees to join the dignitaries on the stage for a group photo. It is our honor to welcome Mr. Kshitish Prabhu, an alumnus of PGP 2015-17 batch and an elected member of IIM Udaipur Alumni Council. Currently, a partner at Cura Capital. Please join me in welcoming Mr. Kshitish Prabhu to the stage to share a few words on behalf of the Alumni Council.
Good morning, everyone. Uh, it's to all my members, faculty members, the entire fraternity, the professors who are present there. It gives us as alumni an immense honor as well as uh, a privilege to come back to campus, relive all those old memories of late night strolls, late night canteen discussions, late night assignment submissions. There would be one or two professors always would have a very stringent deadline. And I can see some smiles on students' faces. They must be remembering some name of their faculty, uh, every corner of this campus holds all these memories for us. And I was privileged enough that I was the first batch who stayed in both the campuses. So my first year was in MLSU campus in the city, and the second year was in Balicha campus. Obviously, at that time, there were a lot of things which were happening. The library was different, the sport complex, which Mr. Banerjee was mentioning. Infrastructure was built around, the infrastructure part was built around all that. And it's also about this foundation day is not just about looking at the past. It's also about reaffirming what we are, how long the journey has been, and with the 2030, the IMU vision that we have as members, elected members of the Alumni Council, we also have a vision for us. The very guiding principle, the guiding philosophy for us has been be there and then make it perfect. And on these lines, we made some changes, some contributions that have happened in the past. Almost 2.5 years back, we changed the bylaws of the Alumni Council, the election procedure. We wanted, as the alumni were evolving, the numbers were growing, we also wanted a more democratic, more robust systems. We changed some bylaws, we started conducting elections, all alumni members who could vote in. We also planned to have city level, chapter level meets, right? Because for us also, the volunteers for alumni council, they are also working professionals. For it's not possible to give that 100% of bandwidth. So we decided we'd go for chapter sessions, chapter elections, and post that, what we observed was not just Mr. Banerjee had been very helpful in setting up the entire infrastructure in terms of seed funding, in terms of initiatives, in terms of the guiding principles. That was the very first step that we took. And in fact, yesterday itself, we had a chance to meet a lot of uh, PGP students who were present here on campus. We had our annual general body meeting, getting things into structure. Uh, like Professor Bajeta ma'am was talking about in terms of digital infrastructure, infrastructural things, real infrastructure. We also planned the last 1 year, we have been planning to get a digital infrastructure focused towards alumni. And coming from that finance background, always keep talking about investments. Mr. Banerjee was also talking about investments. I also call them as a human investment. One of the themes that MAM presented in terms of people, that's also investment that we believe is happening to make the association and the entire alumni family. After 2 years, we'll be moving into different fields. You all will be moving into different domains, different verticals. We have also created an exclusively IIM Udaipur alumni website. It's called imualumni.org. The infrastructure is there. And we had worked with the placement committee as well. That initially, even if, let's say I'm hiring for my firm, generally what we used to do, we used to share an email to the alumni office, alumni relations office. They cascade it to the placement committee. Then you get an email from A4 or the placement team. We are in the process of streamlining those operations. Hey, there should be a job portal exclusively. Only the alumni have the access to it, like maybe a Naukri.com kind of a portal, exclusively for IMU Udaipur alumni. Like that's one part that we did. One of the major hits for us in the last 1 year had been the insurance tie-up that we had with Zopper. It was underwritten by Aditya Capital, and that was one of the challenges that we are facing. We were having these queries. My parents are getting old. I need to get these corporate tie-ups. We don't have a clarity in terms of what insurance plans could be. So we had been reaching out to a lot of firms. Hey, if you can do something exclusively for IMD Udaipur alumni, that could be exclusively for us. And we had almost, if I have to talk about in terms of the premiums that we collected, it's more than 80 lakhs plus. We had some super top-ups also in that range of almost close to 1 CR. That's the range of the initiative that we had taken. That was the penetration level we were able to help, and we have been receiving very good feedback on that. There were a few misses as well from our side. Like I said, it was about being there and making it perfect. We've initiated an alumni to alumni mentorship. So back at campus days, you have in the ICG groups, we have students who are coming, faculty and alumni who are coming in from outside, or they give you kind of resume building sessions. This is one of the challenges, even as an alumnus, also we face. We are at the mid stage of our career. What next? College, may you have faculties, no? You'll be able to guide you. Okay, this. You have folks who have just been players 2 years down the line. That was one of the challenges we started. Not work out, but again, we are reframing this year again and again for the exclusively for the alumni. And we are in the process of probably, if things go well, we'll be inviting faculty members as well to kind of give a mentorship to the existing alumni base, be in terms of we have experts in our faculty in terms of maybe artificial intelligence, maybe if somebody is looking for a career switch, or maybe somebody is planning to get back into academia. So all these initiatives are being taken at an alumni council's end. We have also been yesterday in the meeting in the AGBM for Alumni Council. We had this discussion on an alumni fund as well. We already have an incubation center. We already reach out to Mr. Banerjee for anything in case any alumni activity comes up. But we have been discussing, can't we have alumni fund, maybe a micro ticket size kind of fund for students as well. You come up with ideas, maybe immediately out of the college. College is anyway supporting you. But in case if you need any guidance, we are based out of different cities in terms of infrastructure, be it in terms of both digital and physical, be it in terms of mentorship. We have alums who are already co-founders at firms. Is there an opportunity where could be some synergy be built in? That is something which we would be progressing on in this very year as well. Uh, One of the interesting points that we received was also in terms of podcast. So during the last visit that we came in as part of PGP1 and PGP2 1 year and 2 year MBA inductions, a lot of folks came to us, ki, sir, why don't we do some podcasts or getting the alumni in? We initiated that activity. We had some challenges because again, being working professionals, getting the bandwidth a specific slot for a live interaction gets difficult. So this year we started, rather than doing live events, let's do kind of a podcast kind of a model. It's more engaging, and plus it gives you that freedom of time as well. You're not constrained by time that you have to attend the session at that time. So you will see some developments coming up very soon. Uh, all that being said, last but not the least, there has been a tradition for the last 2 years. We have been doing it is in terms of best faculty award. Uh, we had discussions with Banerjee, Mr. Doshi. We had discussions with the alumni body. Okay, hey, let's not just for current batch, but also students who have just graduated. Uh, for that purpose, I would also like to invite one of my alumni batchmates, Mr. Nikhil, to take this forward from here. Nikhil, over to you.
Good morning, everyone. Thanks, Kshitiz. And esteemed dignitaries, it's an honor standing here and, you presenting the Best Faculty Award. The people who immensely influenced our lives when we were in classes and beyond, right? Some of the faculties, our professors, if we talk to them today, it's always a soul changing experience, right? That never goes away. Their affection, their selfless, whatever it is, giving to us, right? And with that, this is something we started 3 years back as an initiative from the side of alumni to recognize and honor. And obviously we cannot do everybody at the same time, so we initiated this award. And we so we have taken voting from the passing year plus the previous 2 year batches, right? So 2 3 years worth of batches have voted for their best influence. I'll just read out what were the parameters that we were looking at when we asked them to vote, right? So excellence in teaching and communication, lasting impact on career and personal growth, mentorship and accessibility, practical relevance of classroom learning, innovation in teaching methods, ability to inspire critical thinking, leadership, and ethical decision making, and finally, overall contribution to the IIM Udaipur community. And with this, we have received good responses from the students and the alumni. And as always, it is a very tight competition, as you know. I mean, you cannot really pick one, right? And the finalists being, I'll just read out Professor Prakash Satyavagisharan, Professor Ankur Kapoor, Professor Pratik Sharma, Professor Rajesh Agarwal, Professor Shalin Gopal, and Professor Dina Banerjee. And and finally, we'll have to pick based on, though it is a very tight competition, we have only one award to give, and that award goes to Professor Rajesh Agarwal. And if you look at the last 3 years of our journey, Professor Rajesh Agarwal has been collecting all these awards. I think he needs to build a new shelf to have to keep this metaphor. I invite Director Ashok Banerjee and our Chief Guest to present the award to Professor Rajesh Agarwal. Thank you, Professor Rajesh Agarwal. Over to you for a few words.
Thank you, alumni. IIM Udaipur is a high performing knowledge institution, and I'm very fortunate to be a part of this institution. This morning, Professor Vijita Doshi talked about Transform You as one of the foundations of this institution. And at the heart of Transform You is a learning inside the class, and that goes beyond the classroom. And I'm very happy to be a part of this journey and very humble for this recognition by the alumni. Thank you very much.
Thank you, sir. It is my great pleasure to welcome today's keynote speaker, Professor Somak Rai Chaudhary, Vice Chancellor of Ashoka University and a distinguished astrophysicist with an illustrious academic and research career spanning India, the United Kingdom, and the United States. He earned his undergraduate degree from Presidency College, the University of Calcutta, and the University of Oxford, and a PhD from the University of Cambridge. Following his doctoral studies, Professor Rai Chaudhary joined the Harvard Smithsonian Center for Astrophysics, where he contributed to the development of NASA's Chandra X-ray Observatory. He subsequently served as a faculty member at the University of Birmingham, UK, for over a decade before returning to India as the Dean of Sciences at Presidency University, Kolkata. He later served as the director of the Inter-University Center for Astronomy and Astrophysics, IUCAA Pune, prior to assuming the role of Vice Chancellor of Ashoka University. A fellow of the National Academy of Sciences, Professor Rai Chaudhary is internationally recognized for his contributions to cosmology and astrophysics. His research spans a broad spectrum of topics, including the study of universe through both ground-based and space-based astronomical observations. Please join us in welcoming Professor Somak Rai Chaudhary.
Please set up.
You may.
Now does it work? Should work. Hmm? This works. Okay. Come back to technology and entrepreneurship at some point. But I would uh, like to begin with what I do. Don't understand what an physicist does. Shall I? Ah, okay. I'm not sure this works. Um, Whenever I tell people I do astronomy, half the people normally put out their hand and ask me whether will I get diabetes or when will I get married and things like that. Um, the thing is, astronomy is actually a pretty old subject. It's one of the oldest subjects of study because if you think of ancient human beings, what did they have to do after dark? They did not have television. All they had to do was look up at the sky. The sky is accessible to everybody. You don't have to pay for it. And then you start wondering what's up there. Very interesting things happen in the sky. They join the dots and make up stories. There is a theory that a lot of our folk tales and from people trying to remember the patterns of stars in the sky to make up things. Astrophysics, however, is a very new subject. It's one of the new subjects, really, really new subjects. And I hope today I'll tell you why. And that is because to apply physics to understand what the universe is, even the sun is or stars are, took us to understand quantum mechanics, nuclear physics. And so, for example, if you ask a question like, what is the sun? We didn't know that till the 1950s. Einstein didn't know what the sun is. Rabindranath Tagore did not know what the sun is. Because you have to understand the process of the sun, you have to understand a lot of this stuff. Similarly, where we are in the universe, how large the universe is, the fact that we live in a galaxy which is full of billions of stars, and there are billions of galaxies in the universe, this is less than 100 years old. And a lot of what I'm going to talk about today has not ended up in textbooks because this is very new. And that is partly because, in order to understand the universe, we have to go to space. And space, going to, is not that old. Um, Putting platforms only from the 60s. So, what I'm going to talk about is why we have to go to space to understand the sky, the universe. And I hope I also bring in some of the Indian aspects. A lot of space-based astronomy is used, not only is being now, but in its conception and connection. So you see the sky. Let me do this. Yeah, good. Thank you. Now does this work? Yes. Okay. Actually, I'm used to
teaching large classes. So I think even without a mic, you would hear me. But anyway, so yeah. So stars, as I said, is a popular subject. So with artists, you would see sky portrayed in many ways, and people always wondered what those things are. Now, if you look at the sky with your naked eye, as everybody has, if you live in a big city, you don't see much of it. But if you go out and look at the sky, you don't see everything like Van Gogh, but you do understand that there are various different things out there. And some stars twinkle, some don't. There are things that change in the sky. There are things that come like comets and go. There are planets that move around the sky, and some things don't move at all. Now, most of history, we have got our information by looking through our eyes. And this is why astronomy is an old subject, because you could just see with our eyes. However, the light that we see with our eyes is only a very small fraction of the light that comes from the universe. And so the eyes are very limiting in understanding the universe, observing the universe. Light, in the most general way, is essentially it's an electromagnetic wave. It comes from electrical and magnetic disturbances that take place in a source of light like this, or in a star or a galaxy, right? And it does not produce just the kind of light that excites our eyes. It produces all kinds of light. It depends on the different kinds of light are characterized by their energy or wavelength or frequency that's related. And you can see the entire spectrum of light is known as the electromagnetic spectrum. And light, actually, if you look at just the middle, I've drawn the whole continuum of the spectrum, as it were, the different kinds of light that there are. And you would have heard of light being, for example, X-rays. X-rays we encounter in many of our life situations. Ultraviolet, infrared, thing that I'm using here has microwaves in it. The mobile phone that I'm using has radio and microwaves in it. They're all different kinds of light, and they differ from the light that we see in our sky with our eyes, just the energy of the kind of radiation that we're talking about. So in general, we call it radiation, and the different kinds of radiation give you different kinds of information about the source. So when you look at a star, you look at with the kind of light that our eyes are sensitive to. If you just look at the sun, it's got this screen is crunching things a little. The sun is more rounder than that. Then you would find that in the different parts of the electromagnetic spectrum, the sun looks very different, right? So if you look at the visual part, which is what our eyes see, the sun is boring. Don't look at the sun. It's not allowed. But you can rig up things by which you can look at the sun indirectly, and you'll see it's just a yellow disk, nothing else. Sometimes you have those little sunspots. Now, at the same time, all these pictures are pictures of the sun taken at different parts of the spectrum at the same time. So you can see in the ultraviolet, you can see the same sunspots, but they're spectacular. And that's because sunspots are actually big magnetic storms that are going up on the surface of the sun, and they produce mostly ultraviolet rays and X-rays. They don't produce much light, right? And these ultraviolet rays and X-rays tell us a lot about what's going on in the sun and what the sun is about. But it has immense consequences on our lives as well, because those sunstorms that are producing these ultraviolet rays also produce a large amount of charged particles that come and hit the Earth. They cause the aurora borealis. They also cause lots of effects on our communication satellites, when the sun is very active. We now know that the sun has 11-year cycle. Now we are very close to the maximum, and a lot of these things are happening on the sun. Now, if you didn't know that the sun, what the sun looks like at the other parts of the spectrum, like radio, infrared, X-rays, you would never understand what the sun is. Another example, the Orion Nebula. A lot of you can spot the Orion Nebula, Kalpurush, in the sky. You see Betelgeuse, you see the sword of Orion, but that's what it looks like in the infrared. And that's because in the middle of Orion, a lot of new stars are being born. As stars are being born, a lot of dust around it glows in the infrared, lower energy than what our eyes can see. And so we would never know that unless we actually see them in the infrared. The Orion Nebula with the naked eye is boring. And if you go in the infrared, you know that you can see a lot of things. Butterflies look so different in the infrared. Even you look different in the infrared. I don't know whether you understand that all of you are sources of light. We are glowing in the infrared. I don't see you. If I switch off all the lights, I won't see you because my eyes only see visual light. But a cat can see you. Anybody in the cat family can see you because their eyes are also sensitive in the infrared. And this is why we use infrared cameras in defense to find out where people are. Because, I mean, our body temperatures determine what kind of light we are emitting. We are emitting about 1 watt. It's like a 1 watt bulb in the infrared, every one of us right now, right? And so if I can see the objects in the sky, in the infrared and in the radio, etc., we can piece together a lot of that stuff. So an astronomer's job is not to tell you your future, but I'd like to think of myself as a detective in a very interesting way. Difference between other kinds of scientists, like a biologist or a chemist, who can walk into a lab, they can poke the mouse they're working with, or they can mix chemicals, and if it goes wrong, can repeat an experiment. I cannot go to the places where I study. I also cannot repeat the experiment. There's only one universe, right? So for an astronomer, what I have to do is I have to piece together the information that I get from the sky through light. And this is why I told you, I'm glad that there is more than one kind of light. Piece them all together and figure out a way of understanding what those objects are. Just from the information that comes to us. I can't even go and get it. I can't design an experiment. And this is why it's important. All of you know the story of the blind people and the elephant, where if you touch an elephant by not seeing them, the person who's touching the legs, touching the ear, touching the trunk, would get a very different view of the elephant. All those people have to talk to each other to then figure out what the elephant is. And that's the astronomer's job. The astronomer's job is almost like a detective that appears at the scene of the murder a month after the murder has happened. Everything's been cleaned, very faint sources of information, and you piece them together and to figure out what the murder is. And this is why astronomy, to turn into astrophysics and a science, has taken such a long time. And it's truly a 20th, 21st century science. And it's just about taking off. Now, I wanted to talk about the small aspects. I don't have too much time. I'm not giving a full course on astronomy. I'm going to give you a little glimpse of an aspect of what we talk about. So as I said, a star, if I look at a star, its color, so our sun is yellow. If you look at the stars, some are red, some are blue, etc., etc., they tell you the temperature of the star. And that's because normally a star, we call them black body, they emit a certain spectrum, and the peak of that spectrum is related to the temperature. So as I said, you are emitting in the infrared because your body temperature is 300 degrees Kelvin. Our sun's temperature is 6,000 degrees Kelvin, so it's emitting yellow-green. A newborn star, it's about 30,000, 20,000 degrees hot. They're emitting mostly in the ultraviolet or blue. And things that are even less hot are emitting mostly in the red. So the color is a very important information. And then what you do is, what's the color? Color is essentially an analysis of the total light that's coming from something. You have an analyzer that breaks up the light into what is known as a spectrum. And the spectrum, if it's high on the red side, it tells you that the thing is red, etc., etc. But it has got a lot of information, not just the broad color, but essentially what's there in the spectrum. So there are many kinds of spectra. You can have a spectrum that is, if you pass it through some kind of a grating or prism or something, it can have a continuous spectrum like our sun has, but on top of it, you have certain parts of that spectrum that are either bright or dark. And that is because if light is coming through a colder nebula or a gas or something like that, it absorbs part of it. And what it absorbs tells you something about the chemical composition of the absorbed light, what is absorbing it, right? So, or if the light that's coming to you is mixed with something else that's emitting light, or it can excite something that emits more light, you can have bright lines associated with it. Okay? This is what the sun's spectrum looks like. It's of course blue to red, and what we've done is we've folded it so that it won't fit in one line, right? It's a very high resolution spectrum. Can you see the amount of information that there is? Each of those dark lines talks about a certain species of chemical element or molecule or atom that is there between the middle of the sun where the light is being produced and us. So it comes through all the layers of the sun, which are cooler than the middle. Some of it gets absorbed at different layers. And each part of the sun then gives us a certain, it's like a barcode, tells you exactly what's in the sun. You would be surprised to learn that one of the most common elements that you know, the second element in the periodic table, helium, which you use in balloons, was discovered in the spectrum. When we took in the 1860s, in fact, from an experiment done in Andhra Pradesh. And helium is just the second element in the periodic table, and it showed up as one of these absorption lines that nobody knew about, and then realized that this is an element, and then it was manufactured, right? And that's why it's called helium, because it's discovered in the sun. So a huge amount of information tells you what the sun is made of. Tells me all the molecules and the atoms and things like that. And from this kind of work, we now know that anything that we are made of is made in stars. The universe started by giving us only hydrogen and helium. Everything else has been made inside a star since the beginning of the universe. Small stars like the sun, our sun is a very tiny star, make elements up to carbon and nitrogen and oxygen. If you want to make elements that are higher than that, you make them in more massive stars. And then you have generations of stars. They make these elements, then they blow up, distribute those elements around them. From those elements, more stars are made. They cook more. So stars are cooking elements. And if you look at your hand and look at all the protein molecules in your hand, which are made up of carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. Other than the hydrogen, everything has been made in some star or the other. Not the same star. So you are the product of many, many stars. We are learning this now. We've learned this only in the last 100 years by analyzing things like this. Now, I told you there's a very deep Indian connection to understanding stars and also understanding that we really need to go to space to understand the universe. And that is because by looking at these different kinds of spectra of stars and understanding why some stars have this kind of a spectrum and other guys don't, these were classified in different kinds of stars, and also looking at the kinds of elements that are inside the stars. This process started in the US at Harvard at the beginning of the 20th century, but nobody could make any sense of why the different classes of stars have different temperatures and different chemical compositions. The connection was made from the work of Meghnad Saha, which was done in Kolkata. And Meghnad Saha came up with something called the ionization equation. He later moved to Allahabad and set up an amazing physics department and developed his theory of ionization. That was done in the 1920s. And this remarkable woman, Cecilia Payne-Gaposchkin, who was the first woman PhD student at Harvard. Harvard started giving degrees to women only in the 1920s. And Cecilia was the first PhD student in astronomy, heard of this work of Meghnad Saha, never met him later, as you can see, and applied Saha's work on this amazing database they had at Harvard of the different kinds of spectra of stars. Harvard had some of the best telescopes all over the world, in South Africa and in the US. And it's a remarkable PhD thesis in which she used Saha's equation to understand why the stellar spectra were like them, right? Connection between those lines that you see and the general temperature of the stars. So then Saha became a very big celebrity, and he went to visit the US and Europe. This is a picture taken at Harvard University where he actually met Cecilia Payne-Gaposchkin is there, and Saha is sitting in the middle, and Harlow Shapley, who was then the director of the Harvard Observatory, also the PhD supervisor of Cecilia, wrote this, that of course Saha is the father and grandfather of many of these papers, the theories that we have now built up to understand the universe, understand the stars. Not many people know this. It's not being talked about at all. What fewer people know is that while developing this theory, and after seeing how Cecilia applied it to understanding stars, Meghnad Saha realized that a lot of the information about what stars are lies in the ultraviolet part of the spectrum. And the ultraviolet part of the spectrum we don't see. Not only don't we see that, it actually is stuck in the atmosphere. It doesn't come through the atmosphere. Why? You know this. You have heard of the ozone layer. The ozone layer is important because it absorbs all the ultraviolet radiation. Otherwise, we'll get skin cancer. But it stops stars, ultraviolet as well. And so astronomers can't see the stars in the ultraviolet because of the ozone layer, which is good. Bad for the astronomers. Saha realized this. He wrote this paper in 1937, and with this paper, he toured the US. He gave lectures around the US saying, if we have to understand the universe and piece together all the different kinds of light that comes to us, we have to send a telescope in the stratosphere above the ozone layer. Ozone layer is just 50 kilometers above us, right? The first person to say this. So to some extent, Meghnad Saha is the father of space astronomy, which is widely recognized within the astronomy community, but not many people know this. This is what the atmosphere does to the entire spectrum I showed you. You can see that if you take the entire range of X-rays, ultraviolet, infrared, microwaves, radio, and I said we really need, like the blind man and the elephant, to understand all of that, to understand stars, the atmosphere is completely opaque to ultraviolet X-rays. It is opaque in the infrared. And it lets through this light that our eyes see. Isn't that a coincidence? It's actually a wonderful feature of evolution that it's evolved our eyes to see the radiation that comes through our atmosphere. If, for example, our eyes were only tuned to the ultraviolet, we would not know about the stars. Rattlesnakes only see ultraviolet. There are no rattlesnake astronomers, right? The cats can see both infrared and normal visible. They can see the stars. It's a wonderful book by Biman Nath, unfortunately only in Bangla right now, but it's going to be translated, which talks about all the different kinds of animals and how they see the sky. Now, we grew up knowing the sky just because of that little coincidence, that little window. So, if you have to understand the whole spectrum and what the universe looks like, we have to go to space. And this is why we had to wait to see the sky. That's what the topic of my talk is. You would go to space in order to understand everything there. And it was suggested by Mingnath Saha that we have to do this in order to understand ultraviolet. Now we know that infrared, X-rays, everything, we have to go up there. So, following up from Shaha's suggestion in the 1930s, from the 1950s, 60s, the US started developing, NASA started developing, once the space program started, telescopes to be sent to space. And the first telescope that went to space, which is a big enough telescope that could study the universe in the ultraviolet, was the Hubble Space Telescope in 1990. There are many others that happened before that. Again, something that people don't hear of much, but AstroSat is one of the most successful space telescopes in space. AstroSat went up in 2015. It has 5 telescopes on this little satellite. I was privileged to be there in the very first meeting in Professor Kasturi Rangan's office when he was space chairman in the mid-90s, when this was conceived. It was good to see 20 years later it actually went up. And it's got an ultraviolet telescope there, as you can see, number 5. And I'll just show you a comparison, again, things that don't get talked about, how India does well. That ultraviolet telescope on AstroSat, if I compare its image quality with the best NASA telescope in ultraviolet, which is on the right, Galax, just look at the quality of image of the same part of the sky and what you see. This is, of course, in negative, but this is on the left is the Indian ultraviolet telescope on AstroSat. On the right is NASA's Galax, same part of the sky, and you can see the image quality that we have and how much more we can see. I circled some parts where you can see a huge difference, right? And so we built the best ultraviolet telescope. Not only did the idea come from India, we built the best ultraviolet telescope that's in space. And now we can study the sky in the ultraviolet. Of course, there are many others in which NASA and ESA have built wonderful telescopes. You know, the James Webb Space Telescope that studies the universe in the infrared. And you also heard that I was involved in building one of the biggest X-ray telescopes. So I'll tell you a little bit about what you get in the X-rays. Go beyond the ultraviolet. In X-rays, there are lots of things that are in the universe that are more than 1,000,000 degrees hot. How do they get so hot? Stars explode. They become 10 million degrees hot. Something that's 10 million degrees hot doesn't emit any light at all, light that's visible light. It emits only X-rays. And so that's why you get supernovae. You get, after a star explodes, it leaves behind very compact objects like black holes or neutron stars. They have very strong gravity, and the gas around them, because of that strong gravity, gets heated up into million degrees. And so you find these X-rays. In the middle of clusters of galaxies, where lots of galaxies are sloshing around, there's a lot of gas that is accumulated in between the middle of galaxies, just because of the gravitational force of all the galaxies around it. This gas gets heated up to 10 million degrees. We didn't know about this till the 1990s, when we sent up our first X-ray telescopes. Why is this important? For example, I'll give you an example. That Crab Nebula you see is a neutron star that was left behind, we now know, in a stellar explosion that happened in 1054 AD, 1,000 years ago. And it's left behind a star that's very compact. It's a whole star, but it's only 10 kilometers across. The size of Udaipur. And it's spinning very rapidly. Now it can encounter another neutron star, and they can collide and collapse to form a neutron star or a black hole. We now know, and I don't know whether you'll be surprised by this, that if you are wearing any gold or platinum on you now, every single atom of gold is made when two neutron stars collide somewhere in the galaxy. That's the only place you can make gold and platinum. Right? And we are only understanding this in the last 20, 30 years, after we've understood neutron stars. We can't make it anywhere else, because it requires a certain pressure and temperature combination, which comes from these things. So this is why this is such an exciting subject, that we can actually start finding these amazing connections between our lives and the stars out there. So I was involved in building this telescope named after Chandrasekhar, the Indian astronomer, who first showed us why neutron stars and black holes are formed through the application of quantum mechanics to astrophysics. He was a student in Cambridge, student of Paul Dirac, and applied quantum mechanics to stars to tell us how neutron stars are formed and black holes are formed. And so this telescope was built by NASA in his honor to go and find black holes and neutron stars. And I'll show you one example of what it does. So this is a telescope that was launched in 1999. It has a very long orbit because it has to go very far away from the Earth. So it is a 64-hour orbit. And it does not observe the universe very close to the Earth, because the Earth has a lot of magnetic field around it. So it's shut down, and then it starts observing for about 40 hours. Then it comes back, and it's shut down again, and things like that. Okay, it's still observing. It was sent up for 5-year lifetime. It has been, 27 years now. It's still working. What do you see with an X-ray telescope? First of all, it's got mirrors that were completely differently designed. You can't build a mirror to focus X-rays like you do optical light. You know that if you have a mirror and you throw an X-ray to it, it will just go right through. That's why you get X-ray images in hospitals. So what you have to do is you have to have X-rays land on a surface at grazing incidence so that it doesn't go through, and slowly, over a very long distance, nudge the X-rays to a camera. This technology was developed in front of my eyes at Harvard in the 90s. And this telescope is a very long telescope. It's like 5 meters long. And it does that. And it finds these energies, finds these energetic photons, which are called X-rays. So I'll give you an example. This is the picture of a galaxy taken with a normal telescope on Earth in optical light. It's called Sene. It's got lots of stars, as you can see, and it's got a middle with lots of dust in the galaxy, like our galaxy also has. Our galaxy is flat, this one is nice and round. But it's got a very, very massive black hole in the middle. And it's also got a lot of these stars that you don't see are neutron stars and black holes. These are compact objects, they're compact stars, which you don't see in this kind of light. But you turn the Chandra telescope on it, and because we built it, we have a lot of guaranteed time on it, so we can actually observe for long periods of time. And here's a million seconds of a Chandra observation of the same galaxy. Looks so different, no? Now, every single thing in this picture is at least 10 million degrees hot. Every single thing in this picture is a few thousand degrees hot, stars. So if you want to know where in the universe you have hot things and cold things, you have to go somewhere else. I had a PhD student whose entire PhD thesis was this picture. And he found that there are 5 black holes in this picture. There's a central black hole in the middle that is actually emitting a jet that is 10 million degrees hot. All that we have to understand where these things come from. But I just wanted to show you what kind of different vision we get if we open up the spectrum and look at other parts of the sky. India's built its own, I know, I told you, X-ray telescope on the same astrosat that was launched in 2015. We had what's called the SXT, the soft X-ray telescope, very similar to Chandra. These mirrors are nested because you nudge X-rays to an instrument. That's the astrosat version of the X-ray mirrors that was built in Tata Institute of Fundamental Research in Bombay. And it's producing amazing results. Astrosat still works. It's been more than 10 years now. So India is getting into this game and can do ultraviolet X-rays and infrared. The space started with Sarabhai and Bhabha, and I'm sure you've seen Rocket Boys, and Rocket Boys actually tells only part of the story. It was meant, the Indian space industry was meant to be a viable space industry that would be commercially viable. It would do things that will have commercial interests. And it did. For a long time, ISRO became one of the leading organizations in the world to produce, for example, weather data. If at a typical American TV channel, you see cloud pictures and how they move, they would have, in the 70s, 80s, 90s, typically come from ISRO, right? Remote sensing. Some of the things ISRO got really, really good at. And then ISRO started doing space exploration and science along with it. You've all heard of Mangalyaan and Chandrayaan. I don't need to go into the details of some of these amazing missions that ISRO produced. And we talk about the jugaad that went into producing low-cost missions that produced the same kinds of exploration of the moon and Mars as other parts of the world have. And now there are 5 really major nations that can produce such things, and India has become one of them. I started by saying that in order to understand the universe, in order to do science, you have to go to space too. And to some extent, these two have come together in many of these missions. Many of these missions not only do exploration and think about where our journeys in space will take us, but also carry payloads. All of these, Chandrayaan, Mangalyaan, carry little payloads that did some investigation on the scientific aspects of not just the moon or Mars, but also observe the universe. There are little telescopes that were sent along with all these missions. And I think moving forward, as we expand the space industry outside ISRO, we need to have this continuity. Some of the amazing things that ISRO has done, the Indian Space Science Organization has done, since ISRO decided to open up its facilities to the scientific community of the country. Till about the 1990s, ISRO manufactured everything themselves. Chandrayaan, Mangalyaan were all conceived and built by ISRO itself at the beginning. And Dr. Kasturirangan, when he became the ISRO chairman, as I said, first conceived of AstroSat, which would be a telescope in space, just because NASA was doing these amazing missions there. And it opened up to the research community and universities in India. And some of these experiments that went up were actually built by the universities and the scientists in India outside ISRO. After I came back to India about 15 years ago, I got involved in Aditya L1, for example. We built the ultraviolet camera for it. Again, the ultraviolet camera that observes the sun, and you see how amazing the sun looks like in the ultraviolet. Aditya L1 was launched in 23, and it is still the best sun telescope that looks at the sun 24 hours. And the ultraviolet camera was actually built in my institute, IUCA in Pune, by a bunch of normal engineers, very small scale. These things are not very big. Aditya is kind of this big, right? But the interesting thing about Aditya is that it does not go around the Earth. It sits in a place in between the sun and the Earth at what is called a Lagrangian point. That's why it's called L1. There are 5 points in the Sun-Earth system where if you put something, it stays. And that is because the force of the sun and the Earth, the gravitational force, and the centrifugal force due to the orbit cancel out. These are called the Lagrangian points. And so ISRO sent this particular object to the first Lagrangian point, which is about 1% of the distance to the sun away from the Earth, right? You can see where it is. And that is because if it orbited the Earth, half the time the Earth would have blocked the sun. You sent it to the Lagrangian point. The second Lagrangian point, there are some very interesting things there. The James Webb Space Telescope that you hear about, Gaia, which is mapping the entire galaxy, they're all sitting in the second Lagrangian point and things like that. So India can launch things to the first Lagrangian point, and we're planning to launch things even further very soon. And that's how, in this amazing technology that ISRO has of actually building orbits which use the gravitational force of the Earth and the planets themselves, rather than use fuel to do the entire maneuver, is something that is part of the jugaad that ISRO does in terms of producing very low-cost missions. Aditya is a very successful mission. You can see some of the pictures taken by Aditya of the sun. As I told you, in the ultraviolet, they are wonderful and monitors the sun 24 hours, and we get real information of what's happening on the sun before something calamitous happens. If, for example, something is about to happen, which is going to take out half the internet, we will know about it from Aditya, right? These are things that ISRO is planning in this science space. We're looking at, see, now we have about 7,000 planets that we know of, which are outside the solar system. When I was a student, we thought our solar system is the only solar system, right? 7,000 planets. In fact, we know of one solar system that has 9 planets around a single star. Now, are any of these habitable? Are any of these have life on it? How do you know? You have to study their atmospheres, and you have to take a spectrum of the atmosphere of the planet to figure out whether there are any molecules that are linked to life, like carbon dioxide or methane, things like that. That's what ExoWorlds is going to do. It's being built by institutes all over India, headed by the IISST in Trivandrum, which is a Department of Space. In fact, Udaipur Solar Observatory, as you know, is part of the DOS. And there are scientists here who are working on some of this stuff. By the way, they are also connected to the Aditya L1. So that's one of the reasons why Udaipur is a good place for solar astronomy. And similarly, the ultraviolet telescope I showed as part of AstroSat, India is planning to build a really big version of it, bigger than the Hubble Space Telescope. These are all happening in ISRO. As part of ISRO's science mission, which comes from the original idea of Sarabhai, the fact that we will not only do commercial work and technology development, but also try to understand the universe. And the center for understanding all this is, of course, the Physical Research Laboratory in Ahmedabad, which is the Science Institute of the Department of Space. But now it has opened up to the entire Indian university ecosystem. So I, sitting in Ashoka University, can work with ISRO in producing these things as well, right? But what ISRO has also done, and this is the final thing I'll say, is that it's now opened up to the private sector in developing all of this. And you saw what happened last week when first launch, 2 weeks ago, the first launch in the private sector happened from a startup that's made up by people who worked in ISRO, who left and built their first company, Skyroot. Vikram is a small rocket that took a payload of about 300 kilograms. ISRO can do 3,000. 300 kilograms, 350 kilograms to an orbit which is 450 kilometers up, and delivered it and showed it can do it. It also delivered all kinds of little things. There are little statues of Indian scientists, and it's just little things that it took as payloads. And now we have very interesting tech startups that are coming up as the Space Act in India has opened up the space sector to private companies. This is where I said I'd make a connection to what you do. Why is it important? The way India has done it is very different from the way the US did it. When you look at what Elon Musk does, SpaceX does, what Bezos' company does, is that they have developed their space industry in a completely different space away from NASA. NASA helps them, but it's kept them at arm's length. They're outside NASA. Whereas all of these startups use the ISRO infrastructure. ISRO has started a company in space which will help startups to use ISRO infrastructure. And this is why Vikram could go up. Vikram's essential design was done by Skyroot, but the testing, the integration, all of this was done within ISRO. The launching was done within ISRO, right? Which the American industry does not do. So it's a very different model. And this is why I think this sector has a chance of taking off. Why does it need to take off? If you look at the budget of ISRO and the global space industry, ISRO's budget this year got a huge boost, much, much bigger than before, but it's still $1.5 billion. Those things don't cost much. I mean, Aditya cost 600 crores, one-fourth the price of a Boeing aircraft. Nothing. But it does a lot of science. It does a lot of bigger things. ISRO's budget is not much. The entire space industry of the world is $500 billion now, more than 500 billion. It aims to become $1 trillion in 10 years. India is one of 5 spacefaring nations with this technology, and we occupy less than 2%. We are dreaming to grow to 40 billion in the next decade, by which time the entire space industry of the world will go to $1 trillion. Right? This ISRO can't do. And this is why we need the sector where entrepreneurship comes in and builds the basics of the space industry of the world. So when you have to build, what do you have to build? What you have to do is you have to build launch vehicles, you have to build rockets, you have to build parts of things that go up in space. Right? One of the things that Vikram took up was a small prototype of something that actually removes space debris. It's a robotic arm. These things have to be built and things like that. I started off by saying I'm an astrophysicist who actually is very interested in space, and I work in space astrophysics. My hope is, and this is the note on which I want to end today, my hope is as India goes into becoming a major player in the global space industry, and we have to reach not 40 billion, but at least 10% of the global industry, maybe 100 billion in the Viksit Bharat range that we are looking at. I hope that people have their eyes on the technology development that helps science. Because eventually it is science and technology that drives the technology that is frontline. To give an example, every one of you has a phone in their pocket, and that has a camera in it, the digital camera. And if you think where the digital camera came from and why it was invented, do you remember 30, 40 years ago how photographs used to be taken? It used to be taken in little films, taken to a chemical lab, and it was developed. When the space telescopes were being made, when the Hubble Space Telescope was being designed, people realized that it couldn't send back those photographs. So the digital camera was designed with space missions in mind. So when you have a science mission, you start pushing the boundaries of technology. And I hope in this particular direction that the Indian space industry is going, should come back to where I started from, which is to say that in order to understand the universe, we need observing from space. And I hope much of the technology development will be connected to doing science from space. I'll stop here and see if anybody has questions. Do you have time for questions? All right. I don't know whether we have.
If there are any questions, please let us know. You can raise your hand.
I haven't quite exceeded 1 o'clock, so. If not, that's all right, because there's lunch waiting. So. Yes.
Thank you for this fantastic vision of India's space voyage and how we are going. It opens up the opportunity for entrepreneurs a lot. As you said, a lot of parts. Just basic question on the state of the art today, like the components and parts that ISRO is building, or how much of it's actually the parts are built in India versus like lenses, for example. Do we have the technology today, advanced technologies, to build those parts in India, or they are coming from outside?
A lot of it's built in India. So I'll give an example. AstroSat, which was launched in 2015, has only one component that was given by the University of Leicester as a collaboration, which would amount to about 2 to 3% of the cost of the mission. And that is because that particular thing we could not make in India at that time. Even now we can't, microchannel plates. Other than that, entire thing was made by, and the interesting thing is, these are all made by small scale family owned industry. A lot of it is MSMEs and small scale industry all over the country. And they're in unlikely places that make little things that you can integrate into these. I didn't talk about India's other big astronomy missions. One of them is the 30-meter telescope that's going to be built in Hawaii. India is a 10% partner, along with Japan, Canada, and the US. The 10% comes from not cash, but kind. And the entire software of these things is written in Pune. The hardware, which, so this particular 30-meter telescope has 492 mirrors. 130 mirrors are made in India. They're ground in Bangalore. The actual blanks are made somewhere else. The electronics that goes with it comes from a small company in Pondicherry, one in Jamshedpur, one in Indore. We discovered these companies. We discovered these companies that can make space quality things. They're qualified by very rigorous methods. You know, if you're sending some electronics into space, it goes through a launch process that has a huge amount of vibration. So it can't come loose. So ISRO has a separate testing facility, and now, that's why I'm saying now testing has to be done in ISRO, but other industry will have their testing facilities, where you take these things and shake them for like few hours at various frequencies, and then open it up and say what's come loose. You have to take them into extremes of temperature. And so if we identify a particular industry, it can be a small scale industry that will produce a space qualifying lens or a mirror or an electronic component, they have to go through this process. This is being done. We don't have that infrastructure in the private sector yet, which the US has, Germany has. And this is why all this testing is done in ISRO. But give us another 10, 20 years. You will see companies that have essentially space qualifying companies, which are startups, will start up, right? And this will be part of this 40 billion I'm talking about. That 40 billion has to go to 100 billion in the next 20 years.
Very nice. It was another separate question. Any comment on, there are a couple of explosions, like ISRO lost last two consecutively. Are we learning from those things?
We do, absolutely. I mean, many things. For example, the second moon landing, of course, the thing that landed, the lander, was broken on landing. So then there was a huge introspection. I was part of that committee that went through 18 months of analyzing why the thing broke. And we had 72 reasons identified. We rectified all of them, and the next one was okay, right? So there's a lot of introspection, and now the private sector is learning from it. You know, I talked about Vikram 1, the Skyroot launch. This is the first private company in the entire world that has been successful in its first launch. The first two SpaceX launches didn't work, right? So, but we learned from SpaceX. We've learned from them, yes. Thank you. Thank you. Thanks very much.
Just one more question. So, very, very informative presentation. Thank you very much for that. A curious question, when we landed on south of Moon, it was a big, success story. Uh, Curious, why it was quite so successful, because when I did a rough math, uh, Moon and Earth distance versus other planets is quite huge. So there was an article about that. You can use Moon as a second launching place. Just I'll be more than happy to know more about it.
No, of course, landing on the moon has many, many, many aspects to it. One is, of course, technology development, right? So, but you're absolutely right. If the goal is to explore space, and one of the goals is to go and explore mining in the solar system, asteroid mining, even mining on the moon. The moon is just full of, moon and the Earth came from the same nebula. It has the same materials. So whatever you get on the Earth, you get on the moon. Except that when the Earth and the moon were formed, they were formed under different conditions. So it's not the same distribution. So you won't get iron at the same depths in the moon as you would get on the Earth, and things like that. There are some things that are closer to the surface, something you have to dig deep. All this is being studied to figure out what kind of mining one can do on the moon. And then you want to mine the asteroids. You can't go straight to the asteroids. You need a base, right? If you go even to climb Everest, you need many bases. And so you have to establish bases which have to be viable bases. Even going to Mars takes years. And so you have to stop somewhere, refuel, stay for a little while and then go, etc. So one needs these bases. So one of the bases will be the space station. India will have its own space station. Then will be the moon. We'll need a base on the moon. Then will be the next step and next step and next step. And so all that needs to be done. Now, can you build a base on the moon? It's not that easy. The moon has no air. Where's the water? So one of the major things that Chandrayaan has found is sources of water on the moon. Chandrayaan 1 found water on the moon. Now we know that the polar caps have a lot of water, but it's in the form of ice. Can we source water from there? We don't know. And this is why I think things won't happen very fast. In our lifetime, we might not see a moon base. Even though Elon Musk says that, I don't believe him. But because all this needs testing. But it will eventually happen. And I think in the end, it is necessary. We are even thinking of moving a lot of our ground-based telescopes to the moon because space is getting so crowded. I mean, Elon Musk, the Starlink satellites, there are tens of thousands of them now. When I started doing astronomy, I used to take a picture of the sky and I'd see stars. Now I see stars and 15 streaks of satellites, Elon Musk's satellites, are along it, right? And very soon, we won't be able to see the sky from the Earth. So maybe we'll have to build telescopes on the moon, things like that.
Thank you, sir, for your interesting insights and kind words. We now invite Professor Anirban Adhikari, Dean, Faculty and Research, to deliver the word of thanks. Please join us in welcoming Professor Adhikari to the stage.
Thank you. Good afternoon. As we conclude our Foundation Day ceremony, I'd like to express my sincere thanks to our chief guest, Professor Roy Chaudhary. Thank you for taking us to the space to watch the sky. I would like to thank our BOG member, Mr. Pranay Chule, for talking about connecting the dots. I'd like to thank our director, Professor Ashok Banerjee, for giving us the roadmap of upscaling. And also, I would like to thank Professor Vijeta Doshi, Dean Programs, for talking about the foundational elements of IIM Udaipur, the 9 foundational elements he talked about. So now I would like to request Mr. Pranay Chule to hand over a token of appreciation to our chief guest, Professor Raj Chaudhary. So now I would like to invite Professor Ashok Banerjee to hand over the token of appreciation to Mr. Pranay Chule. So I'm also happy to share that last year we started Sri Raghuveer Kothi Memorial Scholarship, and this year Anvi Sharma, daughter of our staff, Mr. Sachin Sharma, she will continue receiving the same Sri Raghuveer Kothi Memorial Scholarship. Right. So I'd also like to thank our administrative team led by Mr. Prakash. They did a fantastic job to make this entire program seamless. Thank you very much. So now, as we go back, we'll reflect upon our journey we had last year, and hopefully next year, when we'll be here at the same date, we'll have much more memories to celebrate. Thank you very much, and now I would like to request everybody to please stand up for the national anthem.
हिमाचल यमुना गंगा उच्चल जलधितरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
On behalf of IIM Udaipur, thank you all for being a part of this celebration. We look forward to many more years of growth, excellence, and impact, and being unstoppable with IMU. We now mark the ceremony closed.